Good morning, everybody. Happy remote learning day. I hope you guys all had a good day yesterday playing in the snow, and maybe even today you can play in the snow if you get your work done. We're just going to move on to the next unit since we just took our Unit 3 test. So our next unit starts off in Chapter 2, Section 1, Writing and Graphing Inequalities. So let's just first talk about what an inequality is. You may already have an idea, but an inequality is a mathematical sentence that compares expressions. An inequality contains the symbol less than, greater than, less than or equal to, or greater than or equal to. So those are all our inequality symbols. They're different from equations. Equations, two things are equal, and like this says, an inequality is comparing two mathematical expressions. To write an inequality, look for the following phrases to determine what inequality symbol to use. I would probably have this chart down here written down somewhere. It does a very good job of giving you the symbol and a few words to look for that might represent that symbol. So, this first one, this less than symbol, means it is less than. So this side, the x side, is less than the y side, let's say. X is less than y, that's how you would read it. So you'd use that to represent is less than or is fewer than. Let's talk about the greater than symbol. We read this from left to right saying x is greater than y, or whatever expression is on either side. So once again, that represents is greater than or is more than. Third one, less than or equal to. X is less than or equal to y. We always read these from left to right. Is less than or equal to. Another common phrase would be is at most. Another one is no more than. So if you see any of these three phrases, you're going to be using this symbol right there. And then greater than or equal to. X is greater than or equal to y. Is greater than or equal to. Another phrase is at least, is no less than. So use these three phrases for greater than or equal to. So once again, I would have those written down somewhere. That way I could have them in one spot to look at, to where if I see it on an assignment or a test or something like that, I would be able to find it and know what it means. So example 1, writing inequalities. It gives us three examples, gives us three sentences, and it wants us to write an inequality based on the sentence it gives us. So for letter A, it says a number W minus 3.5 is less than or equal to negative 2. So we're just going to write this as we're reading it from left to right. So a number W minus 3.5, there's part of my expression so far, is less than or equal to negative 2. This would be my inequality for letter A. Can't see my equal to sign. There we go. W minus 3.5 is less than or equal to negative 2. Now let's look at letter B. 3 is less than a number n plus 5. So once again, I'm going to write it as I read it. 3 is less than a number n plus 5. So there would be my inequality for letter B. And let's look at letter C. 0 is greater than or equal to twice a number x plus 1. So 0 is greater than or equal to twice a number x, so 2 times x, plus 1. So there would be my inequality for letter C. Once again, we could have seen any of these phrases. If we saw is at most, we would use less than or equal to. If we saw is no less than, we would use greater than or equal to. So make sure you're looking for those key phrases whenever you get problems like this, where it gives you a sentence and it wants you to write an inequality. Sketching the graphs of linear inequalities. So a solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. It's kind of different from equations. A lot of our equations had just one solution. The set of all solutions of an inequality is called the solution set. So in this chart, we're dealing with the inequality x plus 5 is greater than or equal to negative 2. And we're seeing if these three values over here on the left are a part of the solution set of this inequality. So what we do, we plug these values on the left-hand side in for x into the inequality, and we work down both sides of the inequality. So for negative 6, we get negative 6 plus 5 is greater than or equal to negative 2. Negative 6 plus 5 is negative 1. So we're asking ourselves, is negative 1 greater than or equal to negative 2? Is that a true or false statement? That is a true statement because it only has to meet one of my conditions. It doesn't have to be both greater than and equal to. It's greater than or equal to. So since negative 1 is greater than negative 2, yes, it is a solution to the inequality x plus 5 is greater than or equal to negative 2. So is the inequality true? Yes, it is. Plugging in negative 7. Negative 7 plus 5 is greater than or equal to negative 2. Negative 7 plus 5 is negative 2. So I'm asking myself, is negative 2 greater than or equal to negative 2 a true statement? It is, since negative 2 equals negative 2. So yes, it makes the inequality true. So negative 7 would be a solution to the inequality. Plugging in negative 8. We get negative 3 is greater than or equal to negative 2. Negative 3 is not greater than negative 2. It is also not equal to negative 2. So no, my inequality is not true. So negative 8 is not a solution to my inequality. If you notice, they used a little slash through the greater than or equal to sign. That's what this statement is talking about down here. Recall that a diagonal line through an inequality symbol means the inequality is not true. For instance, the symbol, the greater than or equal to with a slash through it, means is not greater than or equal to. So just keep that in mind as we go through the next example. Excuse me. So it says, tell whether negative 4 is a solution of each inequality. So I'm going to take negative 4, plug it in for x to letter A, plug it in for x for letter B. So letter A, negative 4 plus 8 is less than negative 3. Negative 4 plus 8 gives me 4 is less than negative 3. So I'm asking myself, is 4 less than negative 3 a true or false statement? It's a false statement. 4 is not less than negative 3. So negative 4 is not a solution on letter A. If you plug it in, you get a false statement. It is not a solution. Let's look at letter B. Negative 4.5 times negative 4 is greater than negative 21. Negative 4.5 times negative 4 gives me 18. So I'm asking myself, is 18 greater than negative 21 a true statement? 18 is indeed greater than negative 21, so negative 4 is a solution for letter B. So if you plug it in, you get a true statement. That number is a solution for that inequality. Moving on, graphing inequalities. So the graph of an inequality shows the solution set of the inequality on a number line. So we're just graphing on a number line. We're not using an XY coordinate plane right now. An open circle is used when a number is not a solution, so it's not included in the solution set. A closed circle is used when a number is a solution, so that number is a part of the solution set. An arrow to the left or right shows that the graph continues in that direction forever and ever and ever. So let's look at some examples. Letter A, well, first off, we're just graphing each inequality. So letter A, we have y is less than or equal to negative 3. So I've got some numbers below negative 3. And some numbers above negative 3. So y is less than or equal to negative 3. My y value is representing all the numbers that make this inequality true. So my point, or my number that I'm putting my point on, is negative 3, but I need to make sure I know if it's an open or closed dot. If my inequality has a line under it, meaning it's equal to, in this case it's less than or equal to, that means that my number is also a part of the solution set. So if it has a line under it, it gets a closed in dot. Just like that. Now I have to figure out which way I'm shading. Remember, y is less than or equal to negative 3 is representing all the numbers that are less than negative 3 and equal to negative 3. My black dot is representing the equal to part. All the numbers that are less than negative 3 are all the numbers to the left of negative 3. So I have to shade my graph to the left and put an arrow on it. That represents all my numbers that are less than negative 3. Let's look at letter B. So my number that I'm using is 2. So I want some numbers below 2. Some numbers above 2. So I have 2 is less than x. So there's a couple of ways to approach this one. If I wanted to, I can flip my inequality. But I need to be careful, very, very careful. Do not rewrite it like this. X is less than 2. That is not the case. If I'm flipping my inequality, if I bring my x over here and my 2 over here, I also have to flip the sign. The open part of the inequality symbol has to be with the x. The pointy part has to be with the 2. It has to stay that way if you're rewriting your inequality. So be very, very, very careful in that when you're rewriting it. So my number that I'm putting my point on is 2. So I have to decide if it's an open or closed dot. If you notice on this one, it does not have a line under it. So it's just x is greater than 2. It's not x is equal to 2. So I'm putting an open dot on 2. 2 is not a part of my solution set in this case. It does not equal 2. So now it's reading x is greater than 2. So I want all the numbers that are bigger than 2. So that'd be everything to the right of 2. Shade in my graph. Put an arrow on my shading to let myself know that I'm shading forever to the right, because that's all the numbers that are bigger than 2. And let's look at letter C. The number that I have is 0. So I want some numbers below 0, some numbers above 0. Once again, I do not have a line underneath my inequality symbol, so it's just x is greater than 0. X does not equal 0, so it's an open dot at 0. And I want all the numbers that are greater than 0, which are bigger than 0. So that'd be everything to the right of 0. Shade to the right of that dot. Put an arrow on your shading. There's my graph. Hopefully that's not too bad. I think you guys might have seen this before in pre-algebra. I'm not 100% sure, but hopefully it makes sense if you haven't seen it or you don't remember it. Example 4, writing inequalities from graphs. So here's our example 4. The graphs show the height restrictions h in inches for 2 rides at an amusement park. Write an inequality that represents the height restriction of each ride. So I'm using an inequality to represent all my restrictions on ride A and ride B. And we're using the variable h. So let's do ride A first. Ride A. Using h. And this blue part is my shading. So I'm shading everything to the right of the number 48. So I know 48 is going to be in my inequality. If I'm shading everything that's to the right of 48, that's everything that's greater than 48. So I need to use the greater than symbol. And if you notice, I have this closed dot. So I need a line underneath my symbol. So h is greater than or equal to 48 for ride A. So I'm going to put that over here next to ride A. H is greater than or equal to 48. So what that's saying is, for ride A, you need to be 48 inches or taller to be able to ride the ride. Ride B. Once again, I know I'm using the variable h. My number for ride B is 52, because my point's at 52. And notice that it's shaded to the left of 52. So that's everything that's less than 52. It is an open dot on 52, so I know there's no line under it. So this is my inequality for ride B. It means you have to be less than 52 inches tall to ride this ride. So I hope you guys saw how we got that from our graphs. If you have any questions, please let me know. Here's just a quick concept summary representing linear inequalities. It has multiple examples where it's the words written out, the algebraic form of those words, and the graph form of those words. So x is less than 2 is this inequality with this graph, and then so on and so forth. You guys can all read that for yourselves and see what that looks like. Once again, if you have any questions, please let me know. I should be available pretty much all day, I would assume, for questions. Make sure you are working on your work. Here's our homework. This will be due, let's say, Tuesday. Nope, let's say Wednesday. Say due Wednesday That would be December 16th on Canvas. Once again, if you have any questions, please let me know. Make sure you're getting these notes taken down and this assignment completed. If you have any missing work, you really need to be getting caught up on that. This is the last week. Friday is the last week. That's the last day of the semester. That's the last day I'm really accepting work. So you need to be making sure you get that turned in. Once again, if you have questions, let me know. Y'all have a good day.